Hello everyone, Mr. Fawcett here, and we are back for part 2 of our lesson on differentiating inverse functions. In this lesson, we're just going to go through some practice problems. So in part 1, we had a thorough discussion of how to derive the formula for differentiating inverse functions, and today we're going to apply that formula. So if you haven't looked at part 1, I'd go back and watch that one before watching this video. We're going to start off with problem number 1 down here, where it's in bold. It says f of x is equal to 5x plus 2, and we need to find the derivative of f inverse of 3. So we need to evaluate that derivative at 3. So if we go back and think about the formula for the derivatives of inverse functions, we know that the derivative of an inverse function, we're just going to call this f. So the derivative of f inverse is equal to 1 over the derivative of the original function, so f prime, of f inverse. Now, here's the nice thing. We can actually, because we know we're evaluating it at 3, you can either go through all the work with just your x's, or you can substitute in 3 immediately. So I'm just going to substitute in 3 immediately. I think that's going to be the easier way here. So this is equal to, actually, I guess let's redo the right side or the left side as well, because we're going to substitute in 3. So I get f inverse of 3 Okay, so the derivative of f inverse evaluated at 3, that is equal to 1 over f prime of f inverse of 3. So we need to find out what f inverse of 3 is. Well, we can't just substitute in 3 to our original function, right? Because that's going to give us f of 3, not f inverse of 3. But we can think about the relationship between f and f inverse, right? Specifically with the domain and ranges. So if I have an x and an f of x table, right, we also can label this as f inverse of x and x, right? The domain and the ranges are switched for functions and their inverses. And I need to figure out what f inverse of 3 is. So I need there to be a 3 in my column for the inputs of f inverse. That's this x. I need there to be a 3 in this column right here, because then I can figure out what my f inverse of 3 is. Well, if I need a 3 in this column, okay, that tells me that f of x is equal to 3. To find the x value when f of x is equal to 3, I can use my original function. So instead of f of x, I have 3 is equal to 5x plus 2. So I get 1 is equal to 5x, which gives me 1/5 is equal to x. So my x value is 1/5. And again, if I substitute in 1/5 to my original function, I get 3. But if I substitute in 3 into my inverse function, like we have down here, that's going to give me 1/5. So this is now equal to 1 over f prime of 1/5. That's the trickiest part of this process. Okay, and that's usually where students tend to make the most mistakes. They forget how to find the values of the inverse function when they're just given the original. All right, and again, it's pretty straightforward if we understand the relationship between the domain and the range of f and f inverse. So now we just have to find f prime, and that's pretty straightforward. It's a linear function, so f of x is equal to 5x plus 2, which means that f prime of x is equal to 5, which means that whatever my value is for x, my derivative is always going to be equal to 5. So f prime of 1/5 is still equal to 5. So I come over here, I get 1 over 5. So 1/5. That is the value of the derivative of f inverse of 3. Or the derivative of f inverse evaluated at 3, rather. That would be the correct way to say it. Okay, let's move on. We're now going to work with a table. So I have a table here, and we are going to use it to complete just part A. So pause the video, see if you can figure out part A, and then give it a listen. So in the table, we're given values for f, g, and both the derivatives of f and g as well. So this is nice. They give us all the values we could possibly need for our equation. And we're actually asked the same question as what we were asked above. What is the value of the derivative of f inverse evaluated at 3? Well, let's run through our same equation again. And I'm just going to substitute in my 3 right away. Okay, so the first thing I want to do is find out what f inverse of 3 is. So actually, I take it back. We do have to go find our inverse values. They do give us our derivative values, but they do not give us our inverse values. So again, no problem. Looking at the table, we can just think about our domain and ranges. If I need to find f inverse of 3, well, relabel your columns. Okay, and I need to find out where in this column I need to find 3. Well, I found 3, and then my f inverse of 3 is going to be equal to 1. So this ends up being 1 over f prime of 1, which is equal to 1 over, if we come over to our f prime column, f prime of 1 is equal to 2. So we get 1/2 is our answer for this inverse function's derivative. Okay, again, you can try B on your own. Same type of process. Practice rewriting your columns so you can understand what the inverse function's values are. And then we're going to move on to number 3. I'm going to make this a little smaller because we are going to try to do both parts if we have time. So again, we're also given a table, and we're now asked a couple of different questions, but we're going to be asked for the equation of a tangent line. So this question is a little different from the ones above. The first part's not, though. We are just being asked for the value of f inverse, the value of g inverse, that derivative, evaluated at 1. So here, the derivative of g inverse evaluated at 1 is going to be equal to 1 over g prime of g inverse of 1. I'm going to come over here to figure out what this value is right here, g inverse of 1. I'm going to get rid of this f column so it's not going to confuse us. And this x column becomes my g inverse column. And this g column becomes my x column. So find 1 in the x column. That's right here, which means my g inverse of 1 is equal to 3. So I get 1 over g prime of 3. That value is given to us, right? G prime column is right here. G prime of 3 is down here. That is equal to -2. So I get 1 over -2, which is just -1/2. All right, then it says find the equation of the line that is tangent to the graph of g inverse when x is equal to 1. So again, we've done tangent lines before. We start off with our general equation. We've already found our m. We've already found our slope because we've done the derivative. That's -1/2. it gives me what my x1 is. So now I just need to find my y1. So when x is equal to 1 for G inverse, what is the value of G inverse? Well, we go to our, let me erase this so we don't get confused. I already have my columns relabeled for G inverse. So I'm going to go down the x column, the green x column, until I get to 1. That's down here. And then I'm going to figure out what G inverse is. That's equal to 3. And I know we've done this before for the equation up here, but it's something that, again, trips up a lot of students, so I think it's worthwhile talking through that process again. So I get y minus 3 is equal to negative 1/2 times the quantity x minus 1. That would be the equation of the tangent line to G inverse at x equals 1. Okay, now for part B, it says estimate the value of G prime of negative 1. What does this say about the graph of G of x at x equals negative 1? So let's clear our work up here, and let's see what we can find out about G prime of negative 1. We have a G prime column, right? The only problem is negative 1 isn't listed, right? The G prime value of negative 2 is listed, and the G prime value of 0 is listed, but not the value of G prime of negative 1. So G prime, right, that represents the slope of the tangent line to G. And we're trying to estimate G prime of negative 1. So we're trying to estimate the slope of the tangent line to G of x at negative 1, at x equals negative 1. So let's just say our function looked like this, and I don't know exactly what type of function we have here, but we'll say that's x equals negative 1, and we'll say our function looks something like this. So what we're trying to do is we're trying to estimate the slope of this line right here. Well, could be drawn a little bit better. Oops, there we go. We're trying to estimate the slope of this blue line right here, the tangent line. This graph represents G of x, so the tangent line of G of x at x equals negative 1. Now, if we can find 2 points right on either side of x equals negative 1 and find the slope of the secant line between those points, again, I am not drawing my lines very well today. If I can find the slope of that secant line, well, the closer those 2 points are to negative 1, right, the better that slope is going to be representative of the slope of the blue line. So the closer those green points are to negative 1, the better the slope of the green line will represent the slope of the blue line. So we're just going to find the slope of the secant line using the 2 points closest to x equals negative 1. Now we have to be careful, right? We were looking at the graph G of x. So we're going to be finding points on either side of negative 1 for G of x, not G prime. So we're going to be looking at these two y values with these two x values. Slope, change in y over change in x, gives me negative 3 minus 2. That quantity all over the quantity 0 minus negative 2. That gives me negative 5 over positive 2, or negative 2.5. So again, this is approximate value of G prime of negative 1. And if our derivative is negative, well, this means that G of x should be decreasing at x equals negative 1. Right? If our derivative is negative, our original function will be decreasing at that point. Okay, so whenever they say estimate the derivative, you can use the slope of the secant line for the original function to do that. All right, let's see if we have time for about one more problem. May look at number 4. Yes, we do have time to go over this one. Similar to one that we've done before, but we'll do it anyway. So it says, given f of x is equal to x cubed minus 1, we need to find the value of the derivative of f inverse at 7. So again, using the same formula here, the derivative of f inverse, the derivative of f inverse evaluated at 7 is going to be equal to 1 over f prime of f inverse evaluated at 7. So we need to figure out what f inverse of 7 is. We're not given that value, but if we're trying to find f inverse of 7, we can look for where the original function equals 7, right? If 7 is in the domain of f inverse, that means it's in the range of f. So I set my original function equal to, not 8, but 7. So I get 7 is equal to x cubed minus 1. Then I get 8 is equal to x cubed, and the cubed root of 8 is 2. So I get 1 over f prime of 2, because f inverse of 7 would give us 2. I don't know what f prime is, but I sure can find it because I'm given, again, f of x. So if I take the derivative of f of x, I'm going to get f prime of x is equal to 3x squared. Derivative of negative 1 is just 0. So if I evaluate f prime at 2, so f prime of 2 is equal to 3 times 2 squared, which is equal to 3 times 4, which is equal to 12. Well, that's going to give me 1 over 12. And that is the derivative of f inverse evaluated at 7. Okay, we'll cover the rest of these problems in class. As always, enjoy the rest of your day, and we will look forward to seeing you next time.